Today we're going to talk about one more example of a related rate. We've been doing lots of these in class, but I want you to see me work out a few that are not alike, kind of a variety from what we've been working out in class. So this says a spotlight on the top of the police cruiser makes 1 revolution per second. The spotlight is 40 feet from a long straight wall. At what rate is the spot of light moving across the wall at the instant when the beam makes a 30-degree angle with the wall? There are lots of ways to talk about this. The 30-degree angle with the wall means this angle. We know, I'm going to just call this y, that y is 40, theta is 30, or pi over 6. We're trying to find dx dt. And then they try and confuse us a little bit. They throw that q in there, but q is not really anything important at this point because the angle the light makes with the wall would be up here where we've already labeled 30. So we know that tangent of theta is going to equal y over x. Now, y is never changing, so we can even put that y in. Tangent of theta equals 40 over x. Now, we need to derive this, and to do that, there's a couple options. I'm going to derive tangent of theta to get secant squared theta d theta dt. And over here, we need, think of it as 40x to the negative 1, and we get negative 40 over x squared as our derivative, because it would be negative 40x to the negative 2. Now, we don't really know much about x, but we can get it at the instance that theta is pi over 6. So, tangent of pi over 6 is equal to 40 over x. When we solve that, we find out that x is equal to 69.282. So, let's plug in what we know. Secant squared theta is pi over 6. They told us that d theta dt is 1 revolution per second. So we didn't talk about this earlier, but that means that d theta dt would be 2 pi radians per second. So we get pi over 6 times 2 pi. Keep in mind that 2 pi is not in our secant squared, and it's equal to negative 40 divided by the 69.282 squared. Times dx dt. Forgot about our chain rule. I forgot about our chain rule. So dx dt. Now, we can do what we need to solve for dx dt. Go ahead and do that. We'll talk about that answer in class tomorrow.